Good morning. We are back. All right, we're going to do more rustlings today, I think. More rustlings. Good morning, Stu. How are you doing? Excuse me. Good to see you. Good to see you. Good morning, Energy Star. Welcome in. How you doing? Olap Depot Dev. Hey, my weekend's going well so far. I just started it. Yeah, I can't complain. Friday ended well, though. The weekend ended on a good note. Good morning, Blips. Good to see y'all. Thank you guys for being here so early. Appreciate you. Yeah, you guys are part of the early crowd today. We're gonna try to do more rustlings. Oh, it's 11:30 a.m. Well, I guess that's what we get for time zones. It's 4:30 here my time, so you're part of my early crowd. Ain't nothing early about this. Yeah, nothing early for you. Let's see, you're 5, 6 hours ahead. So you're across the pond, huh? Energy Star. You're not even in the United States. 6:30 here in Canada. Nice. So you're on the 6:30. You'd be on the East Coast, Eastern Europe. Okay, yeah. You're across the pond, as it were. Let's see, rustlings. There we go. This is what we're going to work on today. CD to rustlings. Also, something with like the winter time changes messes with EU North America time differences. Nice. It's got, I don't know why the time zone thing has to be so complicated. Good morning, Duck Boy. I'd say that's probably one of the worst parts about being a coder, developer, programmer is whenever you have to deal with date and time information. It's just, there's nothing easy about it. It makes you question all reality. What is even today? When somebody says today, what does today mean? It should be 6 hours between EU and Eastern North America, 8 hours West North America. Yeah, it's close to that, right? You're off by an hour. Good day, Ilmanian. Thanks for holding it down on Twitch with Energy Star. We're slowly accumulating some people over there. Good morning, good morning. Nice. Well, I guess we're stuck. We're doomed to suffer against time zone complexity for the rest of our lives. This is our cross to bear. What am I supposed to run to get this to run? Rustlings? Rustlings. Good morning, fellow Steven. I've never seen another Steven in the chat. We have a fellow Stefan in the chat. Good morning, sir. I think YouTube just disconnected. Good morning, Helgoroth. Yep, it disconnected. One sec. We got a closed streamer bot. Oh. I don't know why we've had so many technical difficulties the last 2 weeks. Good morning, crew. Good to see you. Microsoft. Blame it on Microsoft. Blame it on Copilot. Blame it on all Windows related activities. What time do you normally train in the gym? I normally get into the gym. I normally get into the gym usually like mid morning. It depends. It moves around some days. Some days I do it after work, or some days I do it mid morning. But if I can, I like to try to do it at like, 10, 11, something like that. That's kind of my ideal favorite time to train. You can always find a connection if you try hard enough. Yes. Yes, you can. I think I fixed the chat. Yeah, I think I fixed it. All right. Here we go. We're back to doing primitive types. Got to get the sleep out of my eyes. All right. Chat's working. Twitch is good. YouTube's good. We got solid connections. Okay. Steven might be testing chat. I was testing chat. That's what. Well, sometimes. So basically, whenever my Meld Studio disconnects from YouTube, usually I have to restart my streamer bot to get YouTube chat to come back alive. Look, for me at least. I can still see it on YouTube, but I just can't see it in streamer bot, which is the streamer bot's like the tool that I use to do a lot of the stream stuff. Energy Star. Also, something I learned through doing Rustlings. These Rust C -- explain error code the compiler gives at the end of the errors are really good. Okay, I'll have to take a chance on that. Duckboy, I recall someone held a competition to keep their name and everyone else has to change theirs. Not sure about the details. Why why would someone run a competition to keep their name? I mean, it's your name, right? You can do whatever you want. Oh, whoops. I actually hold on before we start into Rustlings. Sorry, apologies. I actually saw that I had a couple people sign up to be members while I was off stream, which is pretty cool. So I should probably update my member list really quick. I like to put those people's names up on the big board. It's snowing here. I don't know what it's like for you guys, but it's snowing. It's super cold too. It's 19 degrees Fahrenheit. All right, give me one sec. I'm gonna negative 16 degrees Celsius. Woo boy, it's getting cold. One sec. You guys are gonna banish for a second. You're gonna come back. Let me just restart this scroll bar. All right, you're back. Now we can. I mean, it's not a lot of snow. I don't know if you guys can even see that. It's not a lot of snow, but it's a little bit of snow. It's like a nice blanket of snow. All I know is it's cold out there. It's hot here. Well, I'm a little jealous, although I kind of prefer cold weather to hot weather myself. Snow fight, yeah, or make a snowman. When my kids were little, that was their favorite thing to do, is make snowmen. All right, we're primitive types, and I think we're on primitive types 4. So we've been making pretty good progress on this thing in a single day. You've never touched snow in your life? Really? Well, that's an experience you got to get at some point, right? The name competition was called Josh Swain Fight. Huh. I've never heard of it, Duck Boy. I don't really understand the point of the competition either. But if somebody was having a good time, you know, who am I to get in the way of that? All right, so what are we trying to do here? Get a slice called nice slice out of the array A so that the test passes. We want to get a slice. I don't think I know how to do that. Slice type. Okay. So what he wants us to do is he wants us to do this. Wants us to do ampersand A. Oh, shut up, Copilot. So he wants us to get the first element. No, the second element all the way to, so we want 1, 2, 3. But I don't think 3 is inclusive, is it? Let's see. I saved that, didn't I? Oh yeah, just took a minute. Left, 2, 3, 4. Yeah, so we got to go up to 4. Hey, look at there. We did it. You can make the x dash y inclusive with equals. Oh, I did not know that. So I could have done, how did I go to the previous one? I guess I can't go back now. Well, that's good to know. Thank you very much, Energy Star. Appreciate that. Silencio, that's right. That's like one of my favorite things I've done to my Neovim command, or Neovim config, is add that command. You should be able to press K when the cursor is over the link and it opens it in your browser. Oh, that's cool. I did not know that. I've been using Neovim for like a year and I didn't know that. Push what? K? L, then K and C. It will swap to the previous one. You should be able to press K when the cursor is over the link and it opens it in your browser. Do I have to be in visual mode for that? Because K to me just moves my cursor up. Oh, capital K, sorry. No, doesn't work for me. I wonder if it's maybe because there's word wrapped. Yeah, Shift K doesn't work for me. Maybe it's something in my config. Then it was probably enter. What? Are you just having me try shit? Yeah, I don't know what you're talking about, buddy. Return or enter just goes to the next line. Are you sure that's a Neovim thing? Neovim. Press K to open link. No, I actually did it a couple times. I feel like you're just making stuff up. Not interested. Yeah, I don't see anything about that on here. I mean, my terminal makes it clickable, but when it's in word wrap mode, it doesn't click the right link unless it's all in the same line, I think. In any event, on to the next one. Excuse me. Destructure the cat tuple in one statement so that the print line works. This I can do. We'll do name and age. Cannot find value second in this scope. All right, use a tuple index to access the second element and assign it to a variable called second. Look at us, we're just flying, man. We're flying. All right, create a vector called v, which contains the same exact elements as in the array A. Use the vector macro. Let v equals, okay. You can optionally experiment here. Okay. Oops. I don't think I know how to use the vector macro, so we should go learn about that. Chapter 8, vectors. All right, creating a new vector. To create a new empty vector, we call the vecNew function as shown in listing 8. Creating a new empty vector, hold values, vect. Yep. Okay, so that's how we create a new vector with the vector macro, but how do we get... Okay, this is about strings. I'm guessing this is not where we want to be. So... how do we do that? I mean, I guess I could just... it said use the vector macro. So what... does it just take A in here? Let's see, mismatch type. Expected struct I32 found rec range. Okay, that's not gonna work. Well, we're gonna use our Google Foo skills. Rust, create an array from, or sorry, create a vector from an array. Oh, whoops, in Rust. Well, that seems dumb. There's got to be a better way to create this thing, but they said create a vector called v, which contains the exact elements as in the array A. Use the vector macro. There's got to be a better way to do this. They want me to literally just index into each one. That seems so annoying. You want me to do this? I don't know if that's what they were wanting me to do, but it doesn't look like there's another way to do it. Hello, world. Yeah, I guess it works. I don't know if that's how I do it. Looks like there's some better options to use to do that. Looks like there's a vec from that works. Or there's an into method. Go figure. They mean for you to manually insert the values. Gee, man, you kind of look like Kevin James. Really? That's funny. Kevin James is funny. Yeah, Kevin James is a good guy. Seems like a nice guy. He played football. He played football, Division III football. He was a running back, actually, if you can believe that. Let's see. A value of type vec I32 cannot be built from an iterator over elements of type unit. Okay. Multiply each element in the input slice by 2 and push it to the output vector. Okay. I think I know how to do this. This would be output dot push, and we do element times 2. And then we do vec map. An example of collecting a vector after mapping, we map each element of the input slice to its value plus 1. Okay, I don't have to do anything here. So this is how you do a lambda in Rust, which looks so odd, but makes sense. Here we also want to multiply each element in the input slice by 2, but with iterator mapping instead of manually pushing into an empty vector. See the example in the function vec map example above. Okay. That would just then be, we're going to get the iterator, and then we're going to say return. Hold on, what we want to do? We want each element in the input slice by 2, but with iterator mapping instead of pushing into an empty array. Okay, so we can then just do this, right? We can say element times 2. I think. Print line. Woohoo! All right, we did it. Look at us. We're making progress. Also, I realize it's kind of small. Next. Which lang is this? Hey, Abu. Good to see you, man. This is Ilmanian. Thanks for lurking. Appreciate you. Abu, this is Rust. These prints are a great idea. I think it's just my obsessive compulsiveness that I can't leave the main function empty. I should probably just leave it empty, but should have thought of that, yeah. All right, now we're mutating stuff. All right, this is important. This is where I think moving is important for understanding ownership, right? Move semantics. Let's see. Fix the compiler error in this function. And what is the error? Cannot borrow vec as mutable as it is not declared as mutable. Vec.push cannot borrow as mutable. Consider changing this to be mutable. Okay, so this is basically saying you can't add an element to a vec. So basically the vec gets passed in, then we're assigning it to a variable, and then I can't modify this new vec because I haven't said, hey, this is a mutable vec. So I have to explicitly say I should be able to put things in here or remove things from it or change things about it. Okay. We did it, chat. All right. I do wish, the only thing, I know everyone has said really good things about Rustlings, and I'm not necessarily disagreeing, but one thing I do wish was a little bit more clear is I do wish it was a little bit more clear what each exercise is trying to get you to understand. What is owner? See, I probably should go and read these sections. Especially for ownership. But I wish it was a little bit clearer. You know, what is this exercise trying to drive home for whatever concept? What is ownership? Okay. I'm gonna read this. So if you're, what's up, Ilmani? Just testing chat there. It'll good to see you too, man. How many languages do you work with? Not very many. Like in my actual day job, I only work with C# and TypeScript. And most of the time, if I'm not learning something new, I'm probably only working with C# and TypeScript. We learned Go for the fun of it to do Advent of Code. And then Rust was kind of a random off-the-cuff thing that we just decided to do. I don't know how much longer I'll stick on it. I'll probably get that Notepad application put away with and then move on. Because I do want to, there's some bigger projects I want to build this year that are going to take me time to work on them, you know? And so streaming eats into about 2.5 or 3 hours of my daily time to code or program. So I need to use some of that time on stream to build those projects. So we'll see how it goes. How you like the journey learning Rust? It's good. Yeah, Imanian, it's good. I thought you were lurking. But I appreciate you chatting. Yeah, it's good so far. I don't see a compelling reason to switch to it in my day-to-day life, but I guess if you're doing low-level, high-performance type of systems programming, maybe it's a more compelling language. But I still don't know necessarily why I would use Rust over C# for most of the work that I do if I'm working server side. But it's good to know. It's good to know new stuff, you know. Good morning, Oblivious. How are you? Welcome in. All right, I'm gonna run through this because I haven't actually read this part of the book, or if I have, I don't remember it. So I'm gonna Let's see. Rust uses a third approach. Memory is managed through a system of ownership with a set of rules that the compiler checks. If any of the rules are violated, the program won't compile. None of the features of ownership will slow down your program while it's running. Because ownership is a new concept for many programmers, it does take some time to get used to. The good news is that you will own nothing and be happy. Rampla, this is not bad advice. This is not bad advice. In 100 years, we'll all be dead. Other people will own our homes, drive our cars. Yeah, 100%. If your happiness is dependent on owning things, it's probably not a good strategy. Omanian, what is the lurk command? Do I forget? The alert command is just !lurk. When you understand ownership, you'll have a solid foundation for understanding the features that make Rust unique. In this chapter, we'll learn ownership by working through some examples that focus on a very common data structure, strings. Awesome. The stack and the heap. Many programming languages don't require you to think about the stack and the heap very often, but in a systems programming language like Rust, whether a value is on the stack or the heap affects how the language behaves and why you have to make certain decisions. Parts of ownership will be described in relation to the stack and the heap later in this chapter. So here's a brief explanation in preparation. Both the stack and the heap are parts of memory available to your code to use at runtime, but they are structured in different ways. The stack stores values in the order it gets them and removes the values in the opposite order. This is referred to as last in, first out. Think of stack of plates. When you add more plates, you put them on top of the pile, and when you need a plate, you take one off the top. Adding or removing plates from the middle or bottom won't work as well. Adding data is called pushing onto the stack. Removing data is called popping off the stack. All data stored on the stack must have a known fixed size. Data with an unknown size at compile time or a size that might change must be stored on the heap instead. Okay, that's pretty straightforward. Craps, am I late? No, you're not late, man. Yeah, we started at like 4:30 today. You just started the stream? Yeah, Veds, we just started probably 30 minutes ago. We're working through the Rustlings exercises and doing a little bit of reading at the same time. Boo, I know TypeScript now. I want to learn Python and C++. How to learn them relating with TypeScript so that I can learn them faster? Yeah, I don't know, man. I think Python, I don't know about C++, but I'm sure Python will be pretty easy to pick up if you already know TypeScript. C++ I have nothing to say about, though, because I've never written any of it or done anything with it. That's a problem. So late today. Why is that? I just got downstairs and was looking for my phone, and then I took a few extra minutes to make coffee, and it's crazy how fast 30 minutes can go when you wake up at 4 o'clock. Like, I woke up at 4 o'clock and I was walking back and forth between the downstairs and the upstairs trying to find my phone. It was dead and I couldn't call it. And then, I don't know, the minutes just slipped away. Yeah. Drowsiness? Yeah, I have no idea. Just, the time seems to go very fast in the mornings. It's a Saturday? It is a Saturday. Yeah, no work today, which is good. You gotta appreciate the man even bothering to wake up at 4. Well, yeah, but if I want to stream, this is the best time. You know, this is the best time to do it. So I gotta get up and make it happen. The heap is less organized. When you put data on the heap, you request a certain amount of space. The memory allocator finds an empty spot in the heap that is big enough, marks it as being in use, and returns a pointer, which is the address of that location. This process is called allocating on the heap, and it sometimes is abbreviated as allocating. Because the pointer on the heap is a known fixed size, you can store the pointer on the stack. But when you want the actual data, you must follow the pointer. Think of being seated at a restaurant. When you enter, you state the number of people in your group, and the host finds an empty table that fits everyone and leads you there. If someone in your group comes late, they can ask where you've been seated to find you. Yeah, I think this is all pretty straightforward stuff. According to you, which is the best language for problem solving? I don't know if there's a best language. You know, I think a lot of best comes down to like the thing you're trying to do with it, your personal preferences as far as like how you like to write code, right? But I think you could probably solve the same problem in a lot of different languages. So I think best is really hard to say. Oblivious. Oh my gosh, I've been watching the stream 18 minutes in the past with YouTube. This is why I prefer Twitch. That's funny. You time traveled 18 minutes into the future now. Feds and problems. So for today, you're going to learn Rust. Don't tell me what you'll just learn it and not take anything, because I can't remember that you made anything with Go because you just learned it for the Advent. So I ended up with Go, I ended up learning Go to do Advent code, which was a ton of fun. And then with Go, I built 2 projects with Go. I built a static website with Go, and then I built a CLI program that allows you to build like tier lists just for fun, which was a lot of fun to build. It uses Bubble Tea, which is like a 2E framework. And then I think with Rust, we'll probably end up just building that Notepad application. So we started building a Notepad application in Rust. So I built this with Go. This was a lot of fun to build. So we could rank programming languages if we want in the terminal. Let's see, what should we do? C#. That goes all the way up there in S tier. Put Python down here in D tier. So I did build a few projects with Go. But yeah, I learned Go to do Advent code, and now I know it, and I can use it if I want to. And then Rust, we're building an application called Zoae, which is basically the name for a baby crab. And this has been a pretty fun project. It's the first time I've built a desktop application before, and we're basically trying to build sort of a alternative to Windows Notepad is what we're trying to do. John Lude, Python and D tier, are we dead ass? No, it's not. It's but the tiers are relative to me. They're not absolute tiers. So for you, Python might be up there in A tier, but for me, Python is D tier. Yeah. So we've been building this. This is like it's still a work in progress, but we're using Rust to do this. So yeah, that's what we're doing. Veds and problems. So we are learning, but we are trying to build. I mean, one of the points of learning is not necessarily always to like become that thing. Like you don't necessarily need to learn Rust in order to become a Rust developer, or learn Go to become a Go developer. Sometimes you learn other things just to get exposure to new stuff and different ways of thinking about problems. And there's always something you can take from a learning experience and sort of fold it into your world and your viewpoint and make you better at the thing that you like to do, which I like to write TypeScript and C#, but that doesn't mean that there aren't things that I can get by learning new stuff. What was the first language I learned? The first language was C#. That was the first exposure I had to programming. Python is like top 2 to 3 best languages for sure. I don't know. For me, it's at the very bottom of the list in terms of the languages I know and like. But I understand it. Are you using Tori? No, I'm using a library called Iced, Minister of Defense. Also, good morning. Sorry, I missed a lot of you coming in. What's up, Cyberlenka? Good to see you. Yeah. Yep. I think I got everybody. Aerobic. Good morning, Aerobic. Got any recommendations for someone starting out making coffee? I think pour over is a safe bet, Cyberlenka. I think getting yourself like a Hario V60, so little ceramic pour over, is probably a good bet. It should go dog water. Not one person like Python. I think some people like Python. I think a lot of people like Python. Why did you stop tiering stuff? Just because that's not really why that's not really the point of streaming today. But I was just trying to demonstrate that, like, Veds Improv and asked if I had built anything with Go, basically. So I was just trying to demonstrate that I did build something with Go. Most developers start with Python. Python is used for a majority of tools and services. Java and JS up there as well. Yeah, that's. I think when I looked at that employability survey from last year, Java and Python were like the top. I think it was Python, Java, and JavaScript were like the top 3 languages for employability, which I think is, that's something we should listen to if you're trying to get a job and maintain a job. Python is literally the best worst language ever created. Yeah, I mean, I don't really. I mean, the thing is, I always try to be like clear about this. That like, it's not that I think Python's a bad language. It's that just my own personal preferences. Like, it's not the language that I reach for. You know what I mean? It's not like my lack of interest is not a criticism of the language. Like Python because of AI and ML stuff. Yeah, it seems like if you want to be in the AI or ML world, you need to get comfortable with being a Pythonista for sure. Good morning. It's 10 p.m. for me. Nice. It's 5 a.m. for me. So I always assume it's morning for everyone else. I know that's not the case, but I don't think I'm ever going to fix that. Let's see. As long as you use it for that niche thing, it's good at. It's really freaking good. Outside of that, it is not good. Heading to Code and Coffee in Boston today. Nice. Yeah, there's a Code and Coffee here in Kansas City. Remember, Minister of Defense, you were telling me that about Code and Coffee and everything, and I had told you that there wasn't a Kansas City chapter. Well, literally like the week after we had that conversation on stream, there's a Code and Coffee group that was meeting here in KC that partnered with the larger Code and Coffee organization. So I think now we officially have one, which is pretty cool. Don't say that. Python will bite you. Why not C++ for employability? I don't know why. I'm just going based off the survey results I saw. I'm not even. I'm sure. I'm guessing C++ was on there somewhere. I just don't remember where it was. They kind of called out and highlighted the top 3. Rishapal, hey, I'm given the task of creating a scraper for a site that blocks bots aggressively, and the scraper need to scrape around 100k pages daily. Dang, sounds like a task, man, for sure. Fewer and fewer code bases are being started in C++. Is mostly why. Yeah, I would imagine. Yeah, I would imagine in today's world. Yeah, not as many. Oh, nice. Are you going to start going to the Code and Coffee, KC? I think I would like to go. I've never been before, but yeah, I think I would like to go. They meet every Saturday from like, I think the time is like 9 to 11 or 11 to 1 or something. Use cases and popularity, ease of use determine the best language to learn for employability. Yeah, I would think ubiquity would be another good factor. Is like how many people are using that language. Especially, it seems like geography matters too. Like if you're here in Kansas City, Java and .NET will most definitely get you a job. But I think if you're in, I don't know, if you're in San Francisco, that's probably not as true of a statement, you know? I use C++ for data and game development. Nice. Is having coffee daily affect sleep cycle badly? Abu, mine doesn't. Caffeine does have a pretty long half-life though, and each person kind of has individual differences in how fast they metabolize caffeine. But I think the half-life of caffeine, sorry, is something like 12 hours or something close to that. So it will affect your sleep for sure. So that's why you got to stop drinking it at a certain point in the day. C++ is a mess. I haven't heard about Quant with Rust or Rust standard for NASA programming. I haven't either. I don't even know really what Rust. I mean, I've heard people say things are built with Rust, but I don't really know too much about what are the big projects that are using it in really big ways. Oh, sorry. I was reading the ownership section. All right, where were we? Accessing data in the heap is generally slower than accessing data on the stack because you have to follow a pointer to get there. Contemporary processors are faster if they jump around less in memory. Continuing the analogy, consider a server at a restaurant taking orders from many tables. Excuse me. It's most efficient to get all the orders at one table before moving on to the next table. Taking an order from table A, then an order from table B, then one from A again, and then one from B again would be a much slower process. By the same token, a processor can usually do its job better if it works on data that's close to other data, rather than further away, as it can be on the heap. When your code calls a function, the values passed into the function, and the function's local variables get pushed onto the stack. When the function is over, those values get popped off the stack. Keeping track of what parts of code are using what data on the heap, minimizing the amount of duplicate data on the heap, and cleaning up unused data on the heap so that you don't run out of space are all problems that ownership addresses. Once you understand ownership, you won't need to think about the stack and the heap very often. But knowing that the main purpose of ownership is to manage heap data can help explain why it works the way it does. So ownership helps us reduce, or ownership helps us manage data that is allocated to the heap, and thus that helps us avoid issues or make our code faster or better since we don't have to use the heap as much, I guess is the takeaway I get from that. First, let's take a look at the ownership rules. Keep these rules in mind as we work through the examples that illustrate them. Each value in Rust has an owner. There can only be one owner at a time. When the owner goes out of scope, the value will be dropped. Variable scope. Now that we're past basic Rust syntax, we won't include all the function main open curly brace code in the examples. So if you're following along, make sure to put the following examples inside a main function manually. As a result, our examples will be a bit more concise, letting us focus on the actual details rather than boilerplate code. As a first example of ownership, we'll look at the scope of some variables. A scope is the range within a program for which an item is valid. Take the following variable. The variable s refers to a string literal, where the value of string is hard-coded into the text of a program. The variable is valid from the point at which it's declared until the end of the current scope. Line 4.1 or listing 4.1 shows a program with comments annotating where the variable s would be valid. This scope is now over. Yeah, so basically s is in scope within the curly braces. Okay. At this point, the relationship between scopes of variables are valid is similar to that in other programming language. Now we'll build on top of this understanding by introducing the string type. To illustrate the rules of ownership, we need a data type that is more complex than those we covered in data type section of chapter 3. The types covered previously are of a known size, can be stored on the stack and popped off the stack when their scope is over, and can be quickly trivial copied to make a new independent instance if another part of the code needs to use the same value in a different scope. But we want to look at data that is stored on the heap and explore how Rust knows when to clean up that data, and the string type is a great example. So if I'm mapping some of this understanding back onto my C# knowledge, in C# we typically think of things being two types. We think of things being reference types or value types, right? Value types end up on the stack, reference types end up on the heap. And so in the Rust world, they sort of have a similar concept. So ownership comes into play when you're dealing with things that can be stored or will be stored on the heap, is when ownership really comes into play. And so the string type is one of those types. So we'll concentrate on the parts of string that relate to ownership. These aspects also apply to other complex data types, whether they are provided by the standard library or created by you. We'll discuss non-ownership aspects of string in chapter 8. Fair enough. Let's see, we've already seen string literals where a string value is hard-coded into our program. String literals are convenient, but they aren't suitable for every situation in which we may want to use text. One reason is that they're immutable. Another is that not every string value can be known when we write our code. For example, what if we want to take user input and store it? It is for these situations that Rust has the string type. This type manages data allocated on the heap, and as such is able to store an amount of text that is unknown to us at compile time. You can create a string from a string literal using the from function like so. Okay, so we have string literal, we have string. String goes on the heap because we don't know how big that string can be. We'll discuss the syntax more in the method sections. Okay, this kind of string can be mutated. Wonderful. So what's the difference here? Why can string be mutated but literals cannot? The difference is in how these two types deal with memory. Yeah, I think that makes sense though, right? A literal is a known fixed size at compile time, whereas a string is something that can dynamically change. In the case of a string literal, we know the contents at compile time, so the text is hard coded directly into the final executable. This is like using like a const in C#, right? If you use like a constant string in C#, this is why string literals are fast and efficient. But these properties only come from the string literals immutability. Unfortunately, we can't put a blob of memory into the binary for each piece of text whose size is unknown at compile time and whose size might change while running the program. With the string type, in order to support a mutable, growable piece of text, we need to allocate an amount of memory on the heap, unknown at compile time, to hold the contents. This means memory must be requested from the memory allocator at runtime. We need a way of returning this memory to the allocator when we're done with our string. So the first part is done for us. When we call string from, its implementation requests the memory it needs. This is pretty much universal in programming languages. However, the second part is different. In languages with a garbage collector, the GC keeps track of and cleans up memory that isn't being used anywhere. Yeah, so this is the stuff I'm used to. I'm used to, like in C#, just like allocate strings like nobody's business, and that's somebody else's job to deal with it. Garbage collection? No, I don't do that. That's someone else's job. We don't need to think about it. In most languages without a GC, it's our responsibility to identify when memory is no longer being used and to call code to explicitly free it, just as we did to request it. Doing this correctly has historically been a difficult programming problem. If we forget, we'll waste memory. If we do it too early, we'll have an invalid variable. If we do it twice, that's a bug too. We need to pair exactly one allocate with exactly one free. Rust, but this is also why people have pain points when they're working in C, right? Because then you have to call, what is it, malloc? You have to call like two keywords all the time to manually ask for memory and then release the memory. So it's painful to do this manually too. I don't know. I think I would be okay with not having to do it manually. Although apparently there's something, I've been watching another YouTuber's videos on C programming, and he's been talking a lot about arena allocators. I have no idea what he's talking about, but apparently it makes memory management in C easier. I don't know if you guys have ever heard of that. I'm guessing C# uses malloc. Yeah, I have no idea how the GC works in C#. I just know it's there and it does its job. Aerobic. I don't know what Ada is, but sounds like a Nintendo game. Yeah. Rust would be bad with quants, but NASA is more about memory safety. Currently, most of the code is written in Ada. Rust is a good Ada replacement. Interesting. I've never heard of Ada before. Boo. So you don't have coffee at night? Not typically. I try to avoid coffee later in the day. Sometimes I violate that rule, but for the most part. Jolie, hi there. I'm watching you from Indonesia. Well, hi. Good to see you. Hope Indonesia's treating you well. See you, Imanian. Have a good day, man. Thanks for hanging out. Appreciate you. February of 1980. Interesting. Yeah, I've never heard of it. All right, this is the natural. Hold on. Where were we? Yeah, Rust takes a different path. The memory is automatically returned once the variable that owns it goes out of scope. Here's a version of our scope example from listing 4 using a string instead of a string literal. There's a natural point at which we can return the memory of our string needs to the allocator. When S goes out of scope, when a variable goes out of scope, Rust calls a special function for us. This function is called drop. It's where the author of string can put the code to return the memory. Rust calls drop automatically at the closing curly bracket. Interesting. So there's like an implicit call to a function that you don't see. In C++, this pattern of deallocating resources at the end of an item's lifetime is sometimes called resource acquisition is initialization. The drop function in Rust will be familiar to you if you've used RAII patterns. This pattern has a profound impact on the way Rust code is written. It may seem simple right now, but the behavior of code can be unexpected in more complicated situations. When we want to have mutable variables use the data we've allocated on the heap. Let's explore some of these situations. Okay. I think that's what I've been running into, is like, I try to build things in the way that I'm used to building things in other languages, and then I run into the borrow checker. It kind of shows how companies don't like switching from true and trusted langs with critical infrastructure and system. Oh, 100%. Why? I mean, what the risk of switching, like if something's working, the risk of switching is way outweighs the benefits, right? Especially for something like, I would assume, like space travel. Academic institutions always use the most niche programming languages of all time. Yeah, what's the one that I hear people talk about? Haskell. I hear a lot of people talk about Haskell in like mathematics. I think, I'm not gonna lie, sometimes I think programmers, though, they just like to flex on each other by being able to read and write the most esoteric programming languages. It's like, oh, you know JavaScript? Oh, well, I know C#. Oh, you know C#? Well, I know C. Oh, you know C? Well, I know Rust. Well, if I know Haskell. It's just a flex. Hey, Haskell never failed in production because it never made it to prod. Yeah. There's somebody that's using Haskell. Who's the guy that created Haskell? Haskell creator. No, that's not who I'm thinking of. So it's not that guy. There's another guy I'm thinking of that's rather popular. Flex of nerdy people. It is, dude. It is. Nerdy people like to flex on each other with, like nerdy people by definition are kind of erudite in nature. Like, they tend to want to know a lot about a lot of things. And I feel like that's a way that they flex on each other, is like, oh, you know a real obscure technology? Well, I know an even obscure technology. It is very, very nerdy. All right, multiple variables can interact with the same data in different ways in Rust. Let's see, assigning the integer of value of variable x to y. We can probably guess what this is doing. Bind the value 5 to x, then make a copy of the value in x and bind it to y. We now have two variables, x and y, both equal 5. This is indeed what is happening, because integers are simple values with a known fixed size, and these two 5 values are pushed onto the stack. Now let's look at the string version. This looks very similar, so we might assume that the way it works would be the same. That is, the second line would make a copy of the value in S and bind it to S2, but this is not quite what happens. To see what is happening to string under the covers, a string is made up of 3 parts, shown on the left: a pointer to the memory that holds the contents of the string, a length, and a capacity. This group of data is stored on the stack. On the right is the memory on the heap that holds the contents. The representation in memory of a string holding the value hello bound to S1. The length is how much memory and bytes the contents of the string are currently using. When we assign S1 to S2, the string data is copied, meaning we copy the pointer, the length, and the capacity that are on the stack, but we do not copy the data on the heap that the pointer refers to. So I think this is a pretty common thing, right, in a lot of programming languages, this idea that you need to remember that you're not necessarily getting 2 copies of the complex data. You're getting references or pointers or whatever you want to call it to the data in memory. So I think that makes sense. If Rust did this, the operation S2 equals S1 would be very expensive in terms of runtime performance if the data on the heap were the same. Yes, makes sense. Earlier, we said that when a variable goes out of scope, Rust automatically calls the drop function and cleans up the heap memory for that variable. But figure 4.2 shows both data pointers pointing to the same location. This is a problem. When S2 and S1 go out of scope, they will both try to free the same memory. This is known as a double free error and is one of the memory safety bugs we mentioned previously. Freeing memory twice can lead to memory corruption, which can potentially lead to security vulnerabilities. To ensure memory safety, after the line let S2 equals S1, Rust considers S1 as no longer valid. Oh, interesting. So that's where the concept of this has moved comes into play, right? Like that's that at this point you would get some error. Borrow of a moved value. Yes. That I've done exactly this in some of the code that I tried to write for the Notepad app. And then I've gotten around it by calling clone. I've done exactly this. If you heard the terms shallow copy and deep copy while working with other languages, the concept of copying the pointer length and capacity without copying the data probably sounds like making a shallow copy. But because Rust also invalidates the first variable, instead of being called a shallow copy, it's known as a move. In this example, we would say let S1 was moved into S2. So what actually happens is shown in figure 4.4. Yeah, so now this thing right here, right, is no longer, we can no longer borrow or read from it or do things with it, because now if we want to do things with it, we basically have to use the thing we moved it to, which would be S2. Okay, that solves our problem. With only S2 valid, when it goes out of scope, it alone will free the memory and we're done. In addition, there's a design choice that's implied by this. Rust will never automatically creep, or will not creep. Rust will never automatically create deep copies of your data. Therefore, any automatic copying can be assumed to be inexpensive in terms of runtime performance. Interesting. It's interesting, this thing about immutability and copying versus not copying data, and how like there's kind of this fundamental thing that's always in contention where like immutability is great, but at the same time constantly copying and allocating data is expensive and slow. And so no matter if we're talking Go or we're talking Rust, these two there's always this like fundamental contention of like immutability makes things easy to reason about, but then it also you suffer performance cost to trying to maintain immutability. Good morning, Danny. Good to see you. Aerobic. Oh, you know C++? I know C++. I do not know C++. It gets bad when someone mentions, well, I know binary. I mean, it's kind of the ultimate flex, right? Because if you know binary, like, everything else be damned. It just might take you much, much longer to write programs. All right, scope and assignment. The inverse of this is true for relationship between scoping, ownership, and memory being freed via the drop function as well. When you assign a completely new value to an existing variable, be aware when someone says they know Redstone in Minecraft and they're 25 plus. Okay, good to know. Danny, so we're tackling borrow concept. Yeah, so the section of the Rustlings that I'm on right now is talking about move semantics. So I think before I really do these exercises, I think it would be good to just read the ownership part verbatim. I don't know how often I'll do that, because I know it's kind of boring to just sit here and read. But I think it's important. I think this is an important enough topic where I should take the time to do it, you know? Because it seems like this is really what you're going to get blocked on the most when you're trying to pick up Rust and use it to build something. Is you're gonna if you're coming from another language like C#, you're gonna try to do things in such a way that you're always gonna, or at least I found that I'm gonna do things in such a way where I always end up fighting the borrow checker, and I need to understand like what is the borrow checker, what is the compiler trying to tell me that I've done, and how do I then refactor to not do that, essentially, right? Learning Minecraft Redstone would be so cool. I don't know, man. Seems like a lot of investment of time for not much payoff. Other than to say I can just do it. The inverse of this is true for the relationship between scoping, ownership, and memory being freed via the drop function as well. When you assign a completely new value to an existing variable, Rust will call drop and free the original value's memory immediately. Consider this code. We initially declare a variable s and bind it to a string with the value hello. Then we immediately create a new string with the value ahoy and assign it to s. At this point, nothing is referring to the original value on the heap at all, and illustrates the stack and heap data now, or figure 4.5 illustrates. The original string thus immediately goes out of scope. Rust will run the drop function on it, and its memory will be freed right away. When we print the value at the end, it will be ahoy world. Yeah, okay. Yep, I'm tracking. Variables and data interacting with clone. If we do want to deeply copy the heap data of the string, not just the stack data, we can use a common method called clone. We'll discuss method syntax in chapter 5, but because the methods are a common feature in many programming languages, you've probably seen them before. Here's an example of the clone method. This works just fine and explicitly produces the behavior shown in figure 4.3, where the heap data does get copied. When you see a call to clone, you know that some arbitrary code is being executed, and that code may be expensive. It's a visual indicator that something different is going on. Ah, interesting. Okay. So clone is sort of like a key that's like, wait a minute. This might be slow and ugly. There's another wrinkle we haven't talked about yet. This code using integers, part of which was shown in listing 4.5, works and is valid, but this code seems to contradict what we just learned. We don't have a call to clone, but x is still valid and wasn't moved into y. The reason is that types such as integers that have a known size at compile time are stored entirely on the stack, so copies of the actual values are quick to make. This means there's no reason we want to prevent x from being valid after we create the variable y. In other words, there's no difference between deep and shallow copying here, so calling clone wouldn't do anything different from the usual shallow copying, and we can leave it out. Rust has a special annotation called the copy trait that we can place on types that are stored on the stack, as integers are. If a type implements the copy trait, variables that use it do not move, but rather are trivially copied, making them still valid after assignment to another variable. Rust won't let us annotate a type with copy if the type or any of its part has implemented the drop trait. If the type needs something special to happen when the value goes out of scope, and we add the copy annotation to that type, we'll get a compile time error. To learn about how to add the copy annotation to your type to implement the trait, see derivable traits. Okay. Seems like somebody could abuse the copy trait, though, right? I guess is what I'm thinking. Seems like somebody could abuse it. Here are some of the types that implement copy. All the integer types, such as U32, Boolean type, floating points, characters, tuples. Tuples, if they only contain types that also implement copy. For example, I32, but I32 string does not. Well, that's good to know. Okay, this is the part I'm most interested in, because this is the part I think I've struggled with the most while building that Notepad application, ownership and functions. Okay, the mechanics of passing a value to a function are similar to those when assigning a value to a variable. Passing a variable to a function will move or copy just as assignment does. Okay, listing 4.3 has an example with some annotations showing where variables go into and out of scope. Okay. Yeah, okay, so since S is stored on the heap, yeah, I guess I should say, since S's data is stored on the heap, when it gets passed to a function, by definition, the data isn't copied, or part of the data isn't copied, the part that's on the heap isn't copied, so this function call takes ownership of S, which means if I try to use S down here, we're going to get some sort of error because S has moved into this function. But that's not the case for X, because X is a primitive type that implements the copyable trait, and so when X gets passed in to this function, makes copy doesn't take ownership of it. It actually gets a copy of it. Okay, that makes sense. Here then S, however, there's S value was moved. Nothing special happens. Okay. I think I'm following. I think I'm still here. I'm still with you. Okay, so if we tried to use S after the call to take ownership, Rust would throw a compile time error. These static checks protect us from mistakes. No, I don't do that. Returning values can also transfer ownership. Listing 44 shows an example of a function that returns some value with similar annotations as those in listing 43. Gives ownership, moves its return value into S1. Okay, S2 comes into scope. All right, so here's an interesting case, takes and gives back. S2 is moved into takes and gives back, which also moves its return value into S3. Okay, how do we take and give back? This function takes a string and returns a string. Okay. Seems kind of weird, but okay. The ownership of a variable follows the same pattern every time. Assigning a value to another variable moves it. When a variable that includes data on the heap goes out of scope, the value will be cleaned up by the drop unless ownership of the data has been moved to another variable. While this works, taking ownership and then returning ownership with every function is a bit tedious. What if we wanted to let a function use a value but not take ownership? Exactly. So that's what I'm doing in a lot of code in that Notepad app. It's quite annoying. Anything we pass in also needs to be passed back if we want to use it again. Rust does let us return multiple values using a tuple, but still that's pretty annoying. But this is too much ceremony, a lot of work for a concept that should be common. Luckily for us, Rust has a feature for using a value without transferring ownership, references. Okay. So this is interesting. This is kind of like in C# we have this idea of references. And so if you pass a value that's a reference type into a method, right? You're both the outer scope and then the inner scope of your function are talking to the same thing. And so this is essentially allowing you to do the same thing in Rust. But in Rust, the key difference is the ownership, that you have to use references to prevent the outer scope from moving the variable declared in the outer scope. You have to use references to prevent it giving up its ownership to whatever function you're passing that value to. Okay. I think I'm following this, but this is definitely not intuitive to my brain quite yet. This is going to take a little bit of practice to make this second nature. Hey, what's up, Artwork Studios? Good morning, man. Sorry, I was kind of heads down on that book. Sorry I missed you showing up. Guess who got back into C#? Did you get back into C#? I've got a weekend project that I'm planning to hack on for the next 48 hours that involves all C#, so I'm excited. Yeah. I mean, I like other programming languages, but I think we all have our preferences. What's up, Dismal? How are you, man? Good to see you. It's been a minute. I hope life's treating you well. Making a console game right now to remember how to code. I think that sounds like fun. There's somebody in my Discord who's been making a digital pet game, which has looked like a lot of fun. It's basically like it's almost like a system monitor, like kind of like what I have on my terminal here. It's like this type of thing because he shows like system information, but then he has like a digital pet that you can interact with. I thought that was kind of fun idea for a game. Dismal. It's been great. How about you? Yeah, I can't complain, man. Life is lifing, you know. I think my son has a basketball game today, but other than that, it's pretty chill. We got some snow here last night, so it's pretty cold outside. But yeah, I can't complain, man. I'm just hanging out in my basement, drinking coffee, chilling with you guys. I need to. Yeah, he has a basketball game at 10. Assembly is best? Oh, really? You like to write in assembly? I don't know, man. It doesn't seem like fun. but to each his own, right? Like that's the wonderful thing about life. We can coexist, and you can like what you like, and I can like what I like, and we can all have a good time. No snow where I live, just ice and sludge. Yuck. Yeah. Well, the worst part about snow's nice, but the worst part about snow is like the aftermath of snow. Everything's messy, and everything has salt all over it, and it starts to melt. My game is literally a regular text-based game that only special thing is it uses file IO for gameplay. Nice. Yeah, I mean, you don't have to compare your game to his. When you said you're making a console game, I thought, oh yeah, console games are fun. Null pointer. I don't know what that means, but I do want to make some coffee, so I guess, should I take you guys with me to make coffee, or should I just run upstairs and make it? I guess I can bring you guys with me. We can make coffee downstairs today. The dog's feet are always muddy. Yeah, dog's feet are always muddy. You got to keep a towel by the door. Yeah, it's just I mean, it's a lot of fun the first day it's on the ground, but then it's a pain in the butt after that. Let's go field trip. All right, field trip. Hold on, I gotta set up. I don't have the camera set up, so give me one sec. I use this app called DroidCam, and it actually works pretty well. I mean, it's not the best video quality or audio quality, but it does its job. I'm not sure how else you would remote. All right, I'll be right back. Hold on, let me set this up. Echo, turn on the basement lights.
Did we just become best friends? All right, 3,
2, 1, to the coffee station. I'll be right there. Did we get a new follower on Twitch? I think we got a new follower on Twitch. Thanks for the follow, whoever that was. Sorry, I was not paying attention. S1 Cube, thanks for the follow, man. Where am I from? I live in Kansas City, Kansas, the United States. I'm never sure how familiar people are with United States geography, but we're like in the middle of the country. That's a beautiful counter. Oh, I don't know. We started renting this house in September, so we're relatively new to the place. But yeah, it's a nice house. The rent's kind of expensive, but for the most part, it's a decent place to raise the kids. I don't think we'll live here forever. Like, I don't think we'll live in Kansas City forever, but my kids like it here. They like their school, and when you have kids, that's what matters the most, is just creating kind of security and stability for them, you know? Got loud noises. One sec. Oh, I forgot my cup. Sweetheart, you live in Nepal? That's awesome. We literally on opposite sides of the world. The internet is a cool place, isn't it? Like, when in the history of me and you have ever talked? You know? So that's pretty cool. I can now say I know somebody from Nepal. Hey, what's up, Bredner? Good to see you. Raj King, sweet, unclose your world. Shania, nice. Have a nice weekend. Thank you very much. That's so kind of you to stop in and say. I think the reason it's not loud is, it's probably not loud because I'm doing it from my phone. The video and audio quality is always going to be a little sketchy, I think. The internet is the coolest thing made by humans. Yeah, it really is. Good morning, Ulas. Good morning, indeed. Good to see you guys. Welcome in. We're taking a little bit of break from Rust learning to make some coffee, but then we're going to go back. We're learning about ownership this morning. Good morning, Miss Yahiro, I think is how you say your name. Sorry, I probably butchered your username. But thanks for being a member. Appreciate you. What kind of coffee we're brewing? We are brewing, there's nothing fancy about this coffee. It's 8 o'clock coffee, espresso roast. Nothing terribly fancy about it. I just bought a big bag of it at Walmart. Yeah, ownership. Yeah, ownership's kind of a nice emoji. I like the use of the emojis. Take advantage of the member perks. Have you any public NPM packages that are cool? I don't have any that are particularly cool. I did make one that's like a line counter. So it basically, what it does is it basically so you run this npm package in a Git repository, and what it does is it basically spits out a file and keeps that file updated with changes. It basically outputs like a text that you can then show on a stream to basically show like how many files you changed, how many lines have you added or deleted. I published that npm package. Let's see, I published an npm package that's for the company I work for. It's like a API SDK for interacting with my company's API. What else? I think those might be the only two I have on there. Oh, I built, so I'm a really big fan of this framework for building backends in TypeScript called Hano, and I wanted to have a dependency injection system for Hano that was similar to .NET. So I built basically like a DI container that wires up really easily into Hano, that mimics that idea of like, if you're familiar with C#, it mimics the idea of like add singleton, add scoped, add transient. So you can basically register different instances of different types, and then in your code you can ask for them, and the container will just resolve you the instance that you're asking for, which makes it allows you to do inversion of control and dependency injection very easily throughout your code, but have all your like all your registrations, all your service registrations in one central location. I think those are all the npm packages that I've ever built or published, but nothing that anyone uses a shit ton of. Sweetcar, I want to ask, like, you are learning Rust and you do leak code and other thing, right? Do you know exercise or programming like game for C programming? I don't know anything about really C. I've never written any C. I've never done any kind of game programming. I'm learning Rust just to learn Rust for the fun of it. I don't do much leak code. I do advent of code every year, which is what we did in December, but I don't do much leak code. Hano is nice. Yeah, Hano is... I think if you're building a backend in TypeScript, I don't know why you wouldn't use Hano. I know Express is kind of like, especially in the Node world, Express is the good old long-standing standby, but in my opinion, the async await support in Express is just so bad that in 2026, you should probably be looking for other options if you're starting a new project, in my opinion. Somebody used the emotional Jared emote. That's my favorite emote. Nobody uses that enough. It's my favorite emote on my YouTube channel, and I rarely ever see it come up. I need to get something where I can see the chat without having to look down, or something that puts the chat over there so it looks like I'm looking at you guys while I'm talking. All right, coffee's done. Time to go back to the desk. Oh crap. All right, ready? To the office. Did you guys get lost out there? You just go forward and then turn left. All right. Do you guys need me to come back out there and get you? All right. One sec. This way. This way, chat. Come on. This way. All right. Here we go. 3, 2, 1. Returning now. Initiating return sequence in 3, 2, 1. It's such a silly thing, but it's fun. I want to have a better though setup for that. I want to have like a better camera, and I want to have an easier way to switch and to pass the audio. Maybe a goal for 2026. Maybe I make some money off this YouTube thing and can buy some more equipment to make it a little bit more fun. I think oh, there we go. Okay. Maybe you can try coding it. Yeah, I don't. It's not really a code problem. It's more like equipment problem. You know, that's the big thing. I just need some way to run a connection between my computer and a camera out there, because I have another camera that I don't really use. I need to spend some time thinking about how I would accomplish it. Raj King, it really is fun. I was in bed with earbuds on, but when you did count to move to coffee station, I got up, watched what's happening. Well, that's good. I'm glad I got your attention. I'm glad it was fun for you guys too. What did you study like in college? What degree you have, or are you learning from scratch? So I did go to college. Actually, you can't see it if you're on. Actually, I don't know if you guys can see it in either scene. Hold on, one sec. If you look up here, right to my, let me see if I can get my hand to, right here. This is my college degree. I got a degree in biochemistry. Thought I wanted to be a doctor, and then I ended up deciding I didn't want to be a doctor, like junior year of college. And so then I spent the first 6 or 7 years of my life in food science doing product development for a large frozen food manufacturer. And then everything I know about like software and computer programming and networking, all that stuff, that's all just self-taught, self-learned. I mean, I would go back to school in a heartbeat. It's just college is so expensive, you know. You're talking about thousands and thousands of dollars. I just paid off my student loans for my bachelor's degree this year. I paid off right about $23,800 this year in student loans. So I'm officially debt free. Me, my wife, my kids, our whole family, we don't owe money. We don't owe anything to anyone. My exams are starting next month. Start what you do to calm yourself when you didn't have studied anything. Oh, that's tough, man. I never didn't study anything, MD. I was a good student. I took college like super seriously. I always prepared. So I don't have super good advice, because I can't tell you to go back and study more. But you should study. You should make the most of the next month. Imagine if Steven was a doctor, though. Oh, hey guys, welcome back to stream. Today I will perform a cardiac bypass. That would be a wild stream. Yay, debt free. Let's go. Yeah, that was a really big accomplishment. That was a really big goal. A 10-year long goal of paying off debt. It kind of makes me feel that I am not late. No one is late for anything. Nice. Yeah, no one's. I mean, yeah. Especially when it comes to technology, like the crazy thing about technology is you never really are done learning. And what's crazy is like every 10 years, the stuff that used to matter doesn't, and now new stuff matters. So it's really like you can start whenever, you're never behind. The thing I always remember whenever I think that I'm behind is I try to always remember that, you know, there's older people who run marathons in their like 60s or 70s for the first time. So I figure if somebody can get in shape to run a marathon when they're 60 or they're 70, it's probably not too late for me to do something, you know? So you're not late at all. Energy Star, I have a massive problem with studying. If a subject doesn't get my interest, I can't learn it. Well, I think that sounds very, very human, if I'm being honest with you. I think that sounds very, very human. My mic seems like it's peaking a little bit. Not sure why. Test, test. Yeah, that's better, I think. Testing, 1, 2. Yep, that's better. Hello, hello? Yeah. Kirk, there's a lot of performance-based masters like University of Colorado at Boulder, which has an electrical engineering master's with no bachelor's entry. Oh, wow. That's cool. Is it pretty expensive, though, the degree? That's my biggest thing with school, or why I haven't ever tried to go back to school, is just the cost of going back is just so prohibitive. I think, Kirk, you're getting a master's, right, Kirk? I think you said you were either going back to school or in the process of going to school. My brain just refuses to hold any information regarding that subject. I feel you, man. I tell my wife that all the time. I think my wife is very, very smart, but I tell her that, you know, for her, it's interest, it's motivation. You know, if she's really passionate about something, she will go very deep on it. But if she's not interested or passionate about it, she just doesn't have the attention span for it. Which I think a lot of times in her life led people to think of her as being like not late. It's led people to label her as lazy or unmotivated, but really it's just a lack of interest. Danny, I feel bad for not being here for the coffee time. Well, we can do another coffee time. It's only 6 and it's Saturday, so I'll probably stream a little bit later. So we can do another coffee time, assuming you're here. So when we do the second coffee time. Kirk, yeah, it's just a piece of paper. I just didn't finish my bachelor's, so I applied for a performance-based admission. I think that's awesome, Kirk. Dude, I will never knock anybody for going back and getting more knowledge. And while I understand what you're saying about it being a piece of paper, it still does represent the work and effort that you're putting in, you know, and knowledge that hopefully you're acquiring. So I think it's awesome that you decided to do that. I wish I had the guts to go back and do it. For whatever reason, there's a piece of me that just is concerned that economically the payoff won't be there, that I'll spend another, you know, 40 grand to get another degree, but it won't really make a big difference in terms of my economics. But maybe, I don't know, maybe when I'm 50 and I finally get to a point where I can retire, maybe I'll go back to school. Maybe that'll be part of my retirement, is going back and getting some more advanced degrees. Sweetcar, yeah, sometimes we get hit by the thought that says everything is failing apart. You are losing yourself, so you need to remind of everything is okay. Yeah, everything is okay, and everything will be okay. 100%. Most things don't matter. In 20 years' time, most things don't matter. It's really bothering me that my mic keeps peaking. It seems to be whenever I start talking, it peaks. There we go. That's better. Raj King, yeah, programmers are not that active by lifestyle and need to spend time to move our bodies and stay active. Yeah, I love working out, man. It's my favorite thing. Lifting weights. I tell people all the time, it's like God, family, football, lifting weights, programming and coding. If I could, I would much rather be a strength coach full time instead of an engineer, but it's a hard way to make a living compared to being an engineer. Fabulous gamer. Well, here's the handsome dev reading references and borrowing a Rust ditch hole. Oh man, okay. I don't know what the ditch hole's about, but I appreciate the handsome comment. And yes, we are reading about or ownership in Rust. We took a little bit of a coffee break and we're doing a little bit of chatting, but we're going to get back to it now. All right, the issue with the tuple code in listing 4.5 is that we have to return the string to the calling function so that we can still use the string after the call to calculate length. Because the string was moved into calculate length, instead we can provide a reference to the string value. A reference is like a pointer in that it's an address we can follow to access the data stored at that address. That data is owned by some other variable. Unlike a pointer, a reference is guaranteed to point to a valid value of a particular type for the life of that reference. Here's how you would define and use a calculate function that has a reference to an object as a parameter instead of taking ownership of the value. Yep, we've done this already, but now we know a little bit more academically what we're doing. First, notice that all the tuple code in the variable declaration and the function return value is gone. Second, note that we pass ampersand S1 into calculate length, and in its definition, we take ampersand string rather than string. These ampersands represent references, and they allow you to refer to some value without taking ownership of it. Wonderful. The opposite of referencing by using ampersand is dereferencing, which is accomplished with the dereference operator, which is an asterisk. We'll use some uses of the dereferencing operator in Chapter 8 and discuss details of dereferencing in Chapter 15. Let's take a look at the function call here. Yep. So ampersand S1 syntax lets us create a reference that refers to the value of S1 but does not own it. Because the reference does not own it, the value it points to will not be dropped when the reference stops being used. Likewise, the signature of the function uses ampersand to indicate that the type of the parameter S is a reference. So this is like, Oblivious was talking about this the other day in chat, and I think this is where the ownership really comes into play in terms of like a mental load while you're programming. Is when you're writing Rust, you kind of have to always be keeping in mind, where do I want this piece of data to continue to be valid and available for reading or available for reading and writing? And that sort of dictates, that basically dictates the signatures of a lot of your function calls and the signatures of a lot of your variable declarations. And that's the additional mental load I feel when I'm writing Rust. And it's also the place where I have the least experience to know if I'm making the right decision or not. Should I be passing this by value? Should I be passing this by reference? Should I be retaining ownership or should I be transferring ownership? I need more reps to get better at it. I love Rust so much. Well, welcome in, Mo. Good to see you. Rust is good. I agree. Rust is good. Raj King, why do you have headphones on? Do you listen to music or hearing your voice back in the headphones? I just listen to music. So the same music that I have playing through the stream, I play through my headphones. I don't typically monitor my voice though. I don't like the sound of my voice and my own voice in my headphones. But yeah, I just listen to music. And sometimes it's nice. Like sometimes my kids will be hanging out in the basement, and sometimes it's nice to have headphones on just to reduce the sound of the boys being crazy. Likewise, the signature of the function uses to indicate that the type of the parameter S is a reference. Let's add some explanatory annotations. Yep. Yep. The scope in which the variable s is valid is the same as any function parameter scope, but the value pointed to by the reference is not dropped when s stops being used, because s doesn't have ownership. When functions have references as parameters instead of the actual values, we won't need to return the values in order to give back ownership, because we never had ownership. We call the action of creating a reference borrowing. As in real life, if a person owns something, you can borrow it from them. When you're done, you have to give it back. You don't own it. So what happens if we try to modify something we're borrowing? Try the code in listing 4.6. Spoiler alert, it doesn't work. So you can't really pass by value. Passing by value in Rust essentially means you'd have to explicitly clone the data prior to passing to a function. Otherwise, you're moving ownership into the function. Yes, that makes sense. Yeah, 100% makes sense what you're saying, Mo. That I guess that parlance that I used of pass by value versus pass by reference is more of a C# parlance, but that's conceptually, I guess, how I was thinking of it is, do I want to give this? Do I want to transfer ownership? I guess the better Rust way to think of it is, do I want to transfer ownership or not transfer ownership? Is probably the better frame of reference. I was trying once to just watch the tutorial for Rust. This part took me out. Yeah, I think ownership is the unlock. I think if you understand ownership, I think if you understand ownership and you know other programming languages, I think Rust becomes much easier to learn and reason about, based on my own experience thus far. Oh, whoops, I probably should put my phone back on the charger. All right, here's the error. Cannot borrow, what does it say? Cannot borrow something as mutable as it is behind behind a reference. Consider changing this to be a mutable reference. Just as variables are immutable by default, so are references. We're not allowed to modify anything we have a reference to. We can have a mutable reference. Yes, we've done this before. First, we change s to be mut. Then we create a mutable reference with ampersand mut s, where we call the change function, update the function signature. Excuse me. This makes it very clear that the change function will mutate the value it borrows. Mutable references have one big restriction. If you have a mutable reference to a value, you can have no other references to that value. This code that attempts to create two mutable references to s will fail. Yeah. So we actually ran into this in the Notepad application, because basically within a function that accepted a particular object as a mutable reference, I then called a method on that object that itself took a mutable reference to itself, and we caused a bunch of borrow checker errors because of that. So you can't have two mutable references. I guess you can't have two mutable references within the same scope, or within nested scopes, maybe even is a better way to say that. This error says that this code is invalid because we can't borrow s as mutable more than once at a time. The first mutable borrows in R1 and must last until it's used in printline. But between the creation of that mutable reference and its usage, we tried to create another mutable reference in R2 that borrows the same data. The restriction preventing multiple mutable references to the same data at the same time allows for mutation, but in a very controlled fashion. It's something that new Rustaceans struggle with, because most languages let you mutate whenever you'd like. Yes. Yes, they do, and this is where bugs come from. The benefit of having this restriction is that Rust can prevent data races at compile time. A data race is similar to a race condition that happens when these three behaviors occur. Two or more pointers access the same data at the same time. At least one of the pointers is being used to write to the data. There's no mechanism being used to synchronize access to the data. Data races cause undefined behavior and can be difficult to diagnose and fix when you're trying to track them down at runtime. Rust prevents this problem by refusing to compile code with data races. Well, that's wonderful. It gets rid of a whole class of bugs. That's nice. Just not simultaneous ones. As always, we can use curly brackets to create a new scope, allowing for multiple mutable. Yeah, so it's you can't have multiple mutable references within the same scope. Rust enforces a similar value for combining mutable and immutable references. This code results in an error. Oh, so we have a reference to S that's not mutable, and then we try to get a reference to S that is mutable. Woo. We also cannot have a mutable reference while we have an immutable one to the same value. Users of an immutable reference don't expect the value to suddenly change out from under them. However, multiple immutable references are allowed because no one who is just reading the data has the ability to affect anyone else's reading of the data. That makes sense. Note that a reference's scope starts from where it is introduced and continues through the last time that reference is used. For instance, this code will compile because the last usage of the immutable reference is in the print line before the mutable reference is introduced. Okay, that makes sense. The scopes of the immutable reference R1 and R2 end after print line where they are last used, which is before the mutable reference R3 is created. Those scopes don't overlap, so this code is allowed. The compiler can tell that the reference is no longer being used at a point before the end of the scope. Even though borrowing errors may be frustrating at times, remember that it's the Rust compiler pointing out a potential bug early and showing you exactly where the problem is. Then you don't have to track down why your data isn't what you thought it was. I definitely found it very frustrating. I found borrow checker errors to be very, very frustrating. Last time I was here, you were at like 5K subs. Good job. Remember me? Hello, Arrow. Yes, I do remember you. Yeah, the channel's slowly been growing. You know, we're just slow and steady. I'm just, I figure I've got like 20 more years of working ahead of me. So I'll just keep showing up and streaming each morning and keep learning. And maybe people will show up and also enjoy the stream and want to hang out with me. And I'm still surprised that the number keeps going up, but it keeps going up. Rajad King, Steve, how long have you been learning Rust and how much more time will be investing learning it? Asking to get an idea of what time would you spend learning it. So we started learning Rust, what was it, like last Monday, I think is when we did the first stream with Rust. I think what I'll do is I'll probably go through Rustlings and then I'll probably finish that Notepad app, or at least get the Notepad app like publishable, so where I can use it and make changes to it on an ongoing basis as I'd like to. So probably, I don't know, let's say another week or two. You could definitely learn it faster though. Like if you really wanted to, get after it, right? You could spend way more time than I've spent in a single day learning it. And then I think to get really good at it, you probably need to work with it for many months and build many different projects, which I'm not going to do. I just, I'll know it well enough to be able to read Rust code and do simple implementations in Rust code, but I definitely won't be like a Rust developer. Like no one's going to employ me to build Rust stuff for them, at least at this point. So yeah, probably 3 weeks or 4 weeks total. That's about what we spent on Go. I think Go we spent all of November. So we spent like 2 hours for 30 days. So we probably put 60 hours total of learning into learning Go. And we'll probably put roughly the same into learning Rust. Roughly. Good morning, Ali the AI. Good to see you. Love pretending to be busy. I don't know. I don't like pretending to be busy. Mo, you can still move ownership into a func and then return it back. Yes. Yeah, they showed examples of that. Kirk, you can use lifetimes to track borrowing explicitly. That's why you hang it off the ref like ampersand quotation mark A. Yeah, I haven't gotten to anything that talks about lifetimes yet, so that'll be an interesting section for me because I still don't quite understand what's happening with that syntax, but hopefully it'll make more sense to me in the future. Async Rux takes a good dev probably a year. Otherwise, you'd be building synchronous CLI apps, which is a great use. Well, that's good. I will appreciate having the CLI, the ability to build things in Rust in my back pocket. But I still think for most things I'm going to build, I'm probably going to end up reaching for TypeScript or C#. Those are just the languages I prefer. But I like the ability, right, now that I can use Go if I want. I can use Rust if I want. What did you do? I saw you have forked Microsoft and others in GitHub. I made some contributions to the Azure SDK for JavaScript, and I made some contributions to the Playwright library, which is used for test automation. And then a lot of the other things on my GitHub are just my own projects. Never gonna give, never gonna give. Are you singing in the chat now, Artwork Studios? In languages with pointers, it's easy to erroneously create a dangling pointer, a pointer that references a location in memory that may have been given to someone else by freeing some memory while preserving a pointer to that memory. In Rust, by contrast, the compiler guarantees that references will never be dangling references. If you have a reference to some data, the compiler will ensure that the data will not go out of scope before the reference to the data does. Let's try to create a dangling reference to see how Rust prevents them with a compile time error. Missing lifetime specifier. Oh, so this is kind of what you're talking. This is kind of what Kirk was talking about. The error message refers to a feature we haven't covered yet, lifetimes. We'll discuss lifetimes in detail in Chapter 10, but if you disregard the parts about lifetimes, the message does contain the key to why the code is a problem. This function's return type contains a borrowed value, but there is no value for it to be borrowed from. Okay. Let's take a closer look at exactly what's happening at each stage of our dangle code. Dangle returns a reference to a string. S is a new string. Ampersand S, we return a reference to the string. Here, S goes out of scope and is dropped, so its memory goes away. Danger. Because S is created inside dangle, when the code of dangle is finished, S will be deallocated. But we tried to return a reference to it. That means this reference would be pointing to an invalid string. That's no good. Rust won't let us do that. The solution here is to return the string directly. Oh, I see. So basically what's happening there is no dangle creates S and essentially owns S. And so when I return a reference to S, again, I'm not transferring ownership, but the scope of dangle ends while retaining that ownership. I see. And so what we're doing here is we're creating S in the function, and then we're transferring ownership of S to whoever the caller is. So nothing is dangling anymore. Okay, so let's recap what we discussed about references. At any given time, you can have either one mutable reference or any number of immutable references. You can either have one mutable reference or any number of immutable references. References must always be valid. Next, we'll look at a different kind of reference, slices. All right, slices let you reference a contiguous sequence of elements in a collection. A slice is a kind of reference, so it does not have ownership. Here's a small programming problem. Write a function that takes a string of words separated by spaces, returns the first word it finds in that string. If the function doesn't find a space in the string, the whole string must be one word, so the entire string should be returned. Let's look through how we write the signature. So the first word has a parameter of type ampersand string, so we have a reference to a string. We don't need ownership, so this is fine. But what should we return? We don't really have a way to talk about part of a string. However, we could return the index of the end of the word indicated by a space. Let's try that. So we have a reference to a string. We get the string as bytes. We iterate over the bytes. we check to see if the current byte is equal to an empty space, essentially. And then if it is, we return I. Otherwise, we return the length value. The first, okay, because we need to go through the string element by element, check whether values space, will convert our string to an array of bytes using the asBytes method. Next, we create iterator over the array of bytes using the iter method. We'll discuss iterators in more detail in chapter 13. For now, know that iter is a method that returns each element in a collection, and that so the one thing I don't care for, I'm not really sure how they would go about this differently, but the one thing I don't care about the way this Rust book is kind of laid out is they reference concepts that you haven't yet covered, and then they kind of like wave their hand at it, which is kind of, I don't know, it's like maybe the sequencing of the information needs to be rethought about, because it seems like you shouldn't really be talking about concepts that you haven't yet introduced to illustrate another concept. That's just me, though. What do I know? So then wraps the result of iter and returns each element as part of a tuple instead. The first element of the tuple returned from enumerator is the index, and the second is a reference to the element. This is a bit more convenient than calculating the index ourselves. Sounds good. We can use patterns to structure that tuple. We'll be discussing patterns more in chapter 6. In the for loop, we specify a pattern that has I for index in the tuple. Okay. Inside the for loop, we search for the byte that represents the space by using the byte literal syntax. If we find a space, we return the position. We now have a way. Okay, there's a problem. We're returning a usize on its own, but it's only a meaningful number in the context of the string reference. In other words, because it's a separate value from the string, there's no guarantee that it will still be valid in the future. Consider the program. Okay. Word will get the value 5. Yes. This empties the string, making it equal to this. Word still has the value 5 here, but S no longer has any content. Yeah, that's yes, definitely could be a problem. Because word isn't connected to the state of S at all, word still contains the value S. We could use that value 5 with the variable S to try to extract the word. This would be a bug. Yes, having to worry about the index in a word getting out of sync with data in S is tedious and error prone. Managing these indices is even more brittle. If you write a second word function, its signature would have to look like this. Now we're tracking a starting and ending. Luckily, Rust has a solution to this problem, string slices. A string slice is a reference. Okay, so a string slice is a reference to a contiguous sequence of elements of a string, and it looks like this. Rather than reference to the entire string, hello is a reference to a portion of the string specified. We create slices using a range within square brackets by specifying starting and ending index. All right, so now I kind of see the value. Now I'm understanding the value of this, because now this is connected to the source of truth, which means what I'm assuming that means that if this thing changes, these underlying references will be reflective of those changes in a way. Okay, with all this information, let's rewrite first word to return a slice. Yes, so we're returning a slice. Okay, so then let's go back to the example of the bug. We now have a straightforward API that's much harder to mess up because the compiler will ensure the references into the string remain valid. Okay, because this is basically going to detect that, hey, you have a reference to this mutable string and you're trying to clear it. Cannot borrow S as mutable because it's also borrowed as immutable. So here we're borrowing a reference to S, which is itself mutable, but because we have an immutable reference, in this scope, we can't then borrow. Okay, that's pretty cool that the compiler tells you that. That's a cool example. Recall from the borrowing rules that if we have an immutable reference to something, we cannot also take a mutable reference. Because clear needs to truncate the string, it needs to get a mutable reference. So the immutable reference must still be active at that point. Rust disallows the mutable reference in clear and the immutable reference in Word from existing at the same time, and our compilation fails. Not only has Rust made our API easier to use, but it also eliminated an entire class of errors at compile time. That's pretty slick. That's very slick. Man, we're having some good talk in the chat. Oh, that's cool, Raj. Can you work in finance or fintech? Very cool. I'm a terrible Rust dev, so I plead the fifth. I don't. If you're a terrible Rust dev, I don't even know where I fall on the spectrum. Then lifetimes are there to ensure a reference doesn't outlive what it refers to. That makes sense. Seems like you would need to have something like that. I'm unemployed, so I would never listen to anything I say. I don't think your employment invalidates your opinion, man, at all. Let's see, Bob is right. Static lifetimes is the longest, and Rust will always try to use the shortest. That makes sense. Rajad King, I would be willing to vouch for Bob. I've never met Bob in real life, but all my interactions with Bob in stream have been wonderful. Recall that we talked about string literals being stored inside the binary. Now that we know about slices, we can properly understand string literals. The type of S here is a reference to str. It's a slice pointing to the specific point of the binary. This is also why string literals are immutable. Ampersand stir is an immutable reference. It all makes sense now. If you rewind the stream like 6 days ago, I think I was bitching about why are there two ways to type a string, but now this makes sense. String slices as parameters. Knowing that you can take slices of literals and string values leads us to one more improvement of first word, and that's its signature. A more experienced Rustacean would write the signature shown in listing 4.9 instead, because it allows you to use the same function on both ampersand string values and ampersand stir values. If we have a string slice, we can pass that directly. If we have a string, we can pass a slice of the string or a reference to the string. This flexibility takes advantages of deref coercions, a feature we will cover in Chapter 15. Defining a function to take a string slice instead of a reference to a string makes our API more general and useful without losing any functionality. Well, wonderful. Okay, this is where we talk about other slices with other data types. Okay, so we're done reading the sections on ownership. I think now we can go back to Rustlings, and hopefully we'll be able to complete these exercises with a little bit more confidence. Okay. Make both vectors vec0 and vec1 accessible at the same time to fix the compiler error in the test. So what does the compiler error say to us? The compiler error says borrowed of moved value vec0. Value has been borrowed here after move. So why was it moved? So it looks like vec0 is moved into fill vec because fill vec doesn't take a reference to the vec. It actually takes the vec. So ownership gets transferred. Okay, so how do I make vec0 and vec1 accessible at the same time. Let's see. Do I make this? I have so if I transfer, so fill vec needs to be able to mutate the vec that's passed in. So if I make this a reference, then this won't be able to mutate it, right? Expected struct, but found reference. Okay, so that's not the right answer. All right, let's put this back the way it was. I want them to be accessible at the same time. So vec here and this is where the move happens. So we have to prevent the move, right? Yeah, we have to prevent it from moving. So the way I would do that is I would say, well, I don't want to take ownership, I just want to reference it. Okay. So if I reference it though, now we have an issue. Okay, so if I do reference, okay, and then down here we're unhappy because we're returning, okay. So can I return a reference to that vec? Okay, now we're unhappy on vec1. Can't compare vec is not implement. So this is because here we're returning a reference, and this expects not a reference. And this is also unhappy. Cannot borrow a pointer to vec as mutable as it is behind a shared, so the data it refers to cannot be borrowed as mutable. This is where I got to in my own code where I can't. I know, so I see that the thing is complaining, right? And I see that it's complaining about borrow checking, but I'm not sure how to go about making the borrower happy, the borrow checker happy. So I don't know what to do here. So we're gonna ask my good friend Gemini to explain this. Let's see, I'm being asked to complete the following to do. I read the chapter on ownership.
Did we just become best friends?
Thanks for the follow, Berto Code. That's super nice of you. I read the chapter on ownership in the Rust programming language book. So I feel I understand the idea of references and transferring ownership, but whenever I attempt to make changes, I'm just stuck in a constant loop of creating new borrow checker problems. Can you explain to me what I should do but please do it in a pedagogical way so that I can learn, or so I can fill the gaps in my knowledge. Here is the problem. Oh, mighty AI, please help me. I'm a simple human. Did I paste the right code in there? Yeah, I pasted the right code. Now we wait while the AI thinks. You need to make a copy somewhere since they both need to exist at the same time. Vac mute vac in the function signature? Yeah, I don't know. I have no idea. I'm gonna see if good old Jim and I here can try to help get me unstuck. Let's see. There's a logical contradiction in the test requirements versus the function signature. The function fillVec takes ownership, and it intends to modify the vector directly. The test requires vec0 to still exist and remain unchanged. The result, vec1, needs to be the modified version. Because the test requires the original data to stay the same and the result to be different, you fundamentally need two separate copies of the data in memory. The solution, cloning. Oh. Well, I thought cloning wasn't a valid option, so... okay. So the takeaway there is... the takeaway here is that... yeah, I guess the takeaway here is if I look at the test cases are saying vec0 should remain unchanged after it's passed to fill vec. That's basically what it's telling me. Vec1 is saying it should return a modified version, or it should return a vector that has a new element added to it. So that's, if I'm looking at those requirements, that points me to the fact that I need two vector versions. I wonder, though, could I accomplish the same thing without the clone here? So I guess what I'm thinking is, could I do this? Could I say, here's a reference. Yeah, here's a reference to a vector. This is the start. This is what you're starting with. And I don't want to mutate it. And then I say, give me a new vector, and we'll say new vec. And then return the new vec and iterate over. So we'll do 4. Let's see, 4 elements in vec, new vec dot push element. And do this. Mismatch type found. Oh, because this returns a reference and I don't want a reference. So how would I... But this is an int 32. Give me a sec. Let's see. Sorry, I'm doing this. The reason I'm doing this is because this is a way for me to test my understanding. Is if I can accomplish the same thing, but in a slightly different way to try to reinforce conceptually what it is I think I understand. Let's see, Rust, when iterating over a vector, how do I get the elements without them being references? You must consume the vector. Oh, interesting. So this won't work because I'm not consuming the vector. So if I was consuming the vector, this would be okay. I see. I see. Okay. And so you're unhappy. You're unhappy down here because we need to consume you, and then everyone else is going to be unhappy again because we moved ownership of vec0 back into that function. So at some point you're going to have to clone, right? I guess that's the situation we're left in. But couldn't I clone the element like this and basically accomplish everything we talked about? Yeah. Which I guess if I had to guess, this is kind of a half dozen or the other situation. Doesn't work. Why doesn't this work? Let's see. Left is not left. Is this right? Is this? Oh, because I didn't add the new. I didn't push 88 on. That's why. So then down here, I'd say new vec dot push 88. That. Whoops, push. And then this is going to want me to rename this to be. Yeah. Unexpected. Oh. And here. And this needs to be a reference. So I think that going through that exercise helps me better understand. Let's see. Using clone on type I32, which implements the copy trait. Try dereferencing. Okay, so the compiler kind of sees that, hey, you have a reference. You probably don't need to clone this. You just want to dereference it. Okay, so yeah, so you can accomplish. So I wonder if under the hood, cloning the vector kind of does something like this code, right? Because that's essentially what we've done. Is we basically just took all the elements from the thing we passed in, and we just put them into this other thing. But because it's a simple type, since it's a an I32, they're stored on the stack anyways. Okay. Okay. Well, all right. That was helpful. That was a good exercise. W for Rustlings. Ownership. Ownership be ownershipping. That's fun. Okay, this is a very interesting language. I will say that. This is a very interesting language. Wager Kings, it feels so unreadable. Bob, no, half dozen of the others correct. Yeah, exactly. I was like, yeah, I'm thinking basically calling clone on the vec kind of amounts to what I did in that alternative version, right? That's probably what Clone's doing anyways. Yeah, this is a super interesting language. This really makes you think. It really makes you think, but I think it makes you think about things in a good way, because you're constantly thinking, what's mutating what? What's reading from what? How many things are mutating this thing? How many things are reading this thing? Yeah, it definitely makes you think about your code in a different way. But I like it. I like it. What's the theme? Like, why is there so much red? Hold on. What? Sorry, hold on. Let me go back to that scene. See if I can see what you're talking about. Why is there... Oh, this theme in my... in Neovim, my theme, I use... telescope themes. I use... Where is it? Whoops. Sorry. So, I use GitHub's... Oopsies. Be help if I could figure out how to navigate this. I use this one. Oops. Oh my goodness, this is so painful. Some of these themes need to be reinstalled. Okay. Long story short, I use GitHub Dark Dimmed is the theme I use. It's the theme I use. GitHub Dark Dimmed is the theme I use. I think thinking like this helps once you go back to other languages. Oh, for sure. I can see it being super, super helpful. You should probably be using cargo Clippy instead of cargo check. I think Clippy, I might be using Clippy. I honestly don't know. This repo that I cloned has Rust Analyzer set up to use Clippy, but maybe because I don't have Clippy installed, it's not using Clippy. I honestly don't know. But so far, it's been okay. Yes, Fock, you forgot the push 88 part. Oh, thanks for calling that out, man. You saw that before I did. Good morning, Light Aurora. Sorry I missed your first message. Hope you're doing well. Bob Noel, you must consume the VEC is misleading. It kind of is, because when I read that, it made me think that I'm doing something that makes the VEC like invalid, or like I'm mutating it, or like destroying it in some way. Yes, Fock. Clone, clone, clone. Dereference the element. Man, you guys knew what the compiler said before the compiler said any of that stuff. Mo, Clippy is just a linter. Cargo check actually checks for compilation errors. Also, Steven, surprisingly enough, the geometry dash remake I'm making isn't half bad. Nice, dude. Good for you. Clippy is included by default. Okay, cool. So then it should be using it, I would imagine. Don't trust the LLM when it comes to Rust. Fair enough. Fair enough. Good morning, Eddie. How are you doing? Thanks for stopping in to say such a kind message, man. I like it when people drop in just to spread some good vibes. It's nice. Codius, what are you making? I'm currently in the process of trying to learn Rust, and so I'm not really making any. I am building something with Rust. I'm building a Notepad application with Rust. But what we're doing right now is I took a little bit of a break to try out Rustlings so that I could work on understanding some of the ownership and the borrowing concepts a little bit better. Run cargo Clippy and see. Okay, let's see. Cargo Clippy. So let's see. It must be there. Yeah, it looks like it's there. Let's see. Zoe generated 9 warnings. So it looks like there's some lint errors in my application code. Yeah, but it seems to be. I seem to have it. I don't know if it's running it though. That's the thing. I'm not sure. Is this the proper way to configure your repo so that you use Clippy? I guess this is the proper way. Or how do I know if I'm using Clippy? DUR, yeah, that works. I mean, it's not my most complex project, but it's surprisingly not the worst. Well, that's always a nice feeling. Not being the worst is a good feeling. DUR, but also you're running cargo check manually. Try and use cargo Clippy instead. How do I not run cargo check manually? Is that something I need to set up in my Neovim configs? Because I'm not doing anything. I just write the file, and I think Rust is the one doing the... My Rust analyzer LSP is the one that's doing stuff. So all I do is write the file out, and that triggers the cargo check thing you're talking about. My toes are kind of cold. I'm gonna get my slippers. I think my slippers are upstairs. I'll be right back. Alright, I'm back. Are you using Rust and Neovim? No, I'm not. Looks like it should be correct. Like shrug, LazyVim set mine up for me. Yeah, so I'm not sure. My Neovim config is pretty simple. Let's see, edit, Neovim config. It's pretty straightforward. I don't think I did anything really to customize it. I just installed the Rust analyzer and let's see, LSP, Rust. Yeah, this is the only thing I did for Rust. I don't know if there's something I need to set here to make whatever you're saying need to happen. But I'm happy to change it if you think there's a better way to set it up. All right, next exercise. What are we doing here? This seems like the same problem. Fix the compiler error in the function without adding any new line. You can optionally experiment here. Okay, so this is the inverse of what we just did, basically. So what it wants us to do is it wants us to make this a mutable reference, I think. Let's see. Expected type found keyword mut. Without adding a new line. So does that mean I can do mut and then this returns and then you take a reference. Okay, that's not what. Okay, fix the compiler error in the function without adding any new line. All right, so why is it mad? First of all, let's start there. Why is it mad? It's mad because cannot borrow Beck as mutable as it is not declared as mutable. So how do I, do I do this? Yes, okay, so that's how I declare that the thing being passed, because this is just like a variable declaration, right? So that if we go back to kind of mutability 101, if I declare this, let x equals 1, and I do let y equals x, yeah. So basically, this is basically I'm doing the same thing where I'm transferring ownership into the fillvec function, and so when I transfer ownership in, I have to say, okay, this is mutable or it's not mutable when I transfer the ownership in, which is why I put the mut keyword here, and I don't declare this as a mutable reference, because I want ownership to be transferred, but I want it to be transferred in such a way that the function can mutate the thing that was transferred in. So this goes back to breaking, and this fixes it. Or it should fix it, I think. Oh, whoops, I gotta get rid of this. Now everyone's happy, and I think, yeah, we're done. We passed. Okay, so let's print. What do we want to print here? Let's print. Maybe getting the hang of it. Maybe. All right, I'll do the next one. Maybe we're doing it. Looks like it should be correct. Shrug. Lazy Vim set. Oh, I already read that one. One shot it. One shot what? All of Rustlings in a single shot? I don't think that's going to happen today, but the mutt. Oh, you're talking about this right here? Cannot borrow X as mutable more than once at a time. First mutable borrow occurs here. Second mutable borrow occurs here. Okay. Fix the compiler errors only by reordering the lines in the test. Don't add, change, or remove any lines. So we just need to reorder. So can we do this and then... Yes, okay, that makes sense. So we get a mutable reference here.
Did we just become best friends?
Buzztronic, thank you very much for the follow. That's very kind of you. Appreciate you. We get a mutable reference here, and then we use it. And because the last use of it is on line 13, we can get another mutable reference to X on line 15 and use it. That's why that works. And I know that you guys probably know these things, so I hope you don't take it like I'm talking out loud to teach you guys, because I'm not. I'm more of talking out loud to like reinforce my own understanding. I don't want anyone to be like, "What? Why the fuck is Steven telling me? I already know." He's the dummy that doesn't understand Rust. This is just how I learn things. Let's see. We did it again, chat. All right, next one. Next one. Ooh, this one looks kind of involved. Wow, there's a lot of errors in here. Okay, this might be a tough one. We all started out as dummies. You're right, man. I said the other day I don't care for that word either, right? Like I'm not. It's not that I think I'm a dummy or I think you're a dummy, right? It's more of we all start out as ignorant. We all start out not knowing stuff, and that's okay. And that's okay. Hey, what's up, Amba? How are you? Or Amba? Sorry, I never know if I'm supposed to say Amba or Amba. Hi, good evening. Make Y as mutt? No, we just had to reorder the usages. Yo, what's up, 199? Good to see you, man. Hope you're doing well. Welcome to the stream. I need to get a new monitor ASAP. One monitor is torture. Yeah, one monitor is torture, man. I don't know how people do it. I'd like to upgrade my monitors. I have two 27-inch monitors right now, but I really would like to go back to either two 32 inches or get like two stacked ultra wides. I think that would be really nice. It's just expensive. Actually, my name is Manindra, Muni for short. I like Amba. Okay, I'll call you Amba. Having my IDE split 3 ways and my terminal split 2 ways is cramped as fuck. I feel you, man. I feel you. Plus, switching between virtual desktops for note taking. 32-inch for main, then have second monitor vertical. I have a coworker, or he's not a coworker anymore, but he used to be a coworker of mine who used to always have a vertical monitor, and I've never been able to get used to having vertical monitors. See if I can. trying to see if I can force my... For some reason, my heater in my house is not kicking on. It's just the temperature keeps dropping. And I don't know why. Might have some HVAC work to be done later today. Always wasted. What is the arrow in your code? You're talking about this right here? This ligature? That's how you declare a return type in Rust. Also, good morning, Always Wasted. Good to see you. Yeah, it's a return type. Is this exercise for Rust? Yes, it is. This is Rustlings. I put the link to the exercises in the description. It's like a, it's supposed to be like an accompaniment to the Rust programming language book. I'm kind of worried that my heat's not kicking on. It's like 19 degrees outside and my heat's not kicking on. All right, so fix the compiler errors without changing anything except adding or removing references. Okay, so let's see if we can follow. Let's see if we can follow the code a little bit here. So we're in our main. We have some data. This is a string. This should not take ownership. Okay, so which means what we should do is we should pass a reference to a string. And better yet, we could probably pass a reference to a stir, right? And then we can do, give me this. Okay. And then this takes a mutable piece of data. And what are you complaining about here? Mismatch type, expected ampersand string, but found string. So we don't want a reference, we actually want to accept the ownership of it. Now you are going to complain because we're passing a reference, but we don't want to pass a reference anymore. And I think everyone is happy now. Hey, look at there. Rust is great. I love that. Yeah. I mean, it's good. I'm not necessarily convinced. It's great. I mean, it's such a different paradigm. It's such a different way of thinking about your code that it just feels foreign. And it's not really an indictment on the language, right? It's not really a knock on the language. It's just it feels different. All right. So we made it through all the move semantics, which I think is good for today. do git add git commit m feature progress from 2026-01 of 17. Push that up. Oh, it's taking a minute to push. What's happening? Is my internet down? Connect to host. Oh. That's weird. Anybody ever had that issue before pushing to GitHub? I don't think I've ever seen that before. Is GitHub having issues? GitHub status page. Connect to host GitHub.port22. Connection timed out. Cannot read from remote. Please make sure you have the correct access rights and the Git and the repository exists. My stream is still up. It looks like I'm still sending data to Twitch and YouTube, so I don't think it's an internet thing. Maybe it's a GitHub thing. Let's see if something else loads. Let's see, YouTube. Yeah, YouTube loads. This must be a GitHub problem. Can anybody else push to GitHub? Oh no. Oh no, what's happened? Good morning, man. Just curious, how do you put that arrow character map? Is there a key to put an arrow? No, it always wasted. It's called a ligature. It's based on what font you're using. Like, where do I find the exercises for C++? I'm doing Rust reps. I don't think there's a exercise like this for C++, or at least I'm not aware of one. The Rustlings. Sorry, Rust. I think GitHub's down. Ping GitHub? Yeah, maybe. Microsoft got to GitHub? Maybe, yeah. Microsoft Slop got to GitHub? Yeah. Let's see, ping github.com. Yeah, I think GitHub might be down. When did you start Rustlings? We just started yesterday. Who was it? It was Always Wasted was asking. Oh, Twitch disconnected. Why did Twitch disconnect? Nope, I'm in GitHub listening to you. Huh. Weird. Maybe it is a me problem then. It looks like my stream is still up on YouTube from what I can see. Maybe it is a me thing. It doesn't look like I can reach Twitch though. Reps. What about the Rust? Where did you get it? Here, hold on. I got it here. @reps. @repKSO2. There you go. I just put the link in the chat there for you, buddy. All right, something's going on with my internet. But I'm able to get to certain sites, but I can't ping GitHub, and I cannot ping twitch.tv. GitHub outage. Huh. That's super weird, but I can ping, let's see, can I ping my own website? Blog.stephenfreeborn.com. Yeah, I can ping, so I can ping certain sites, but for whatever reason, I cannot get to GitHub and I cannot get to Twitch. Yeah, I don't know. I don't know what I've done. I did something. Because I can't even see Twitch chat right now. DNS? It's always DNS, right? That's so weird. Everything was working just fine, and then it just stopped. All right, let's do some troubleshooting. Yeah. How do we troubleshoot things like this? Well, let's try from my phone. GitHub.com. Go. Okay, GitHub.com loads fine on my phone over my Wi-Fi. So it's something with this machine. What I would have done to break it, I have no idea. Let's try a different browser, maybe? GitHub. That's so weird. All these corpos trust some third party with their sensitive info when it comes to LLMs. Any private DNS? No. Yeah, no, nothing funky. Nothing funky going on my... I mean, I'm sure I have some local host entries. Let's see, host file. I'm sure I have some entries in here. I am using Tailscale. I wonder if that's having an impact. Maybe Tailscale is having an issue. Let's see. Let's try turning off Tailscale. No, that didn't seem to make a difference. I don't know. I'm sorry, Twitch, if you can hear me, Twitch. I wonder if I'm still live on Twitch, actually. It looks like Meld is still sending data to Twitch. This has turned into a Steven troubleshoots his stream issues. Oh yeah, I'm still live on Twitch. Well, Twitch, if you can hear me, I'm sorry. I haven't been looking at your chat because I haven't been able to see it. Alright, well. I don't know what to do, man. Still live? Okay, cool. Thanks, man. Thanks for coming all the way over to YouTube to let me know. I don't know what to tell you, man. We're having technical difficulties. It started all of a sudden, too. I don't really have a good explanation for it. Could be SSH key issue. Yeah, I mean, it could be, but it's interesting that I can't ping it. Right? Like, that's weird. You can't ping that. Yeah, that's GitHub's IP. It's definitely a me thing, though. So weird. Still baffles me how we all flew in from overseas to join stream today. Yeah, we've got people from Indonesia. We had people from Nepal. Yeah. Can you check tail scale responding? Let's see. Tail scale? Yeah. Um, let's see. I can ping a device by its tail scale. Ping bit bastion. Yeah. And that's the thing is, like, I'm still connected to the internet. I can still resolve most of the things, but for whatever reason, I can't resolve github.com and I can't resolve Twitch. And I have no idea why. Let's see what the internet says, huh? Let's see. Unable to resolve github.com. Check your internet connection. Flush your DNS cache. I guess we could try that. So I guess it's not really a DNS problem, though, isn't it? Is it? Because it does resolve github.com to the proper IP. This is the proper IP. So it isn't really a DNS thing. So let's see. github.com resolves to proper IP, but no response. Maybe I need to restart my router, but then if I restart my router, it's the end of the stream. GitHub blocks or ignores ICMP. Oh, you think that's the same case for Twitch and GitHub? Curl. Yeah, it's very odd though. It just I can ping that. Yeah, so it's It just started all of a sudden too, because I was on GitHub earlier today and I was talking to Twitch earlier today. So, go figure. Let's see. Failed to connect. Timed out. Failed to connect. Could not connect to server. Failed to connect. Port 43. I have no idea. I probably think at this point what I would do is I'd restart my computer and also restart my router and see if that fixes it, but obviously then that means the end of the stream. I think it's a SSH pinging it. It is an outlier. Huh. Go figure, man. Go figure. Actually, I do think, though, this has been a good stream. I do think, though, I need to go see what's going on with my HVAC because I've been sitting here for like 30 minutes and I've increased the heat several times and the heat is not going up. So, chat, I think this will be the end of the stream. I'm going to go figure out what's going on with my heat. All right, guys, if you're new here and you want to come back and hang out in the future, my schedule is from 4:15 to 7 a.m. Every morning, Central Standard Time. I just put the schedule in the chat. So if you want to come back and hang out, that's the best place to find us. If you are new here and want to hang out outside of the stream, you can check our Discord. That's just discord.stephenfreeborn.com. And you're welcome to join in. You don't have to. There's no pressure. You do you. But that's the best place to interact outside the stream. This is always the most bittersweet part. Yeah, streams, they always, all good things must come to an end, right? Oh, I can't get to Discord either. What the fuck? I can't get to discord.com. I don't know. I'm gonna figure this out. I'm gonna go figure out what's going on with my heater, which I think my heat just turned on. Are you kidding me? What is happening this morning? The stream is in shambles. Steven is in shambles. I don't know. All right. Well, bye Sequar. Bye Bob Knoll. Bye Amba. Bye Artwork Studios. Bye guys. Appreciate you hanging out with me. It was a lot of fun. Thank you for helping me learn Rust. I really appreciate it, guys. I'm gonna keep trying to stick with it, and hopefully at the end of this, I'll have a better grasp on Rust, the programming language. So we'll see. All right, guys. Have a good day. Appreciate y'all. Bye. Bye, chat. Bye, guys.